All right, so today we're going to be graphing polynomials day 2. So we're going to talk today about zeros and the multiplicity. So multiplicity of a zero is just the degree that of its corresponding linear factors, like how many times it actually occurs in it. So first we want to find the zeros of this. I'd have to factor it. So factor out your x and then factor it. So I get x plus 5 twice. So our zeros right here would be a 0. So x equals 0 and x equals -5. So this one there was only one 0 here, so it has a multiplicity of 1, and that one happened twice. So this one has I can't even spell multiplicity of 2 because it happened twice right there. So on this one, I'm going to pull out a negative x squared and then factor. So my zeros on this one, I'm going to get 0 here, and I'm going to get 3 here. This happens twice because it's a power of 2. So that has a multiplicity of 2. Again, this happens twice. So this one here has a multiplicity of 2 also. All right, so the next example, write that in factored form and then graph it. So factored form first, pull out your x. And then factors of 4 to get 4. Or 2 of those. So this right here is our factored form. So there's a factored form. So then we would have what we need to graph. So in order to graph this, we're going to say that our leading coefficient is a 1, and it's an odd power. So I have a positive odd. So remember from the other day, positive odd means that it's going to go down, up. So it's going to be down on this side and up on that side. My zeros I need to plot are 0 and -2. So 1, 2, 0 and -2. And then my multiplicity, so this one only happens one time. So I'm going to put multiplicity of 1 because there's one of them. This is a multiplicity of 2. So multiplicity of 2 means that it's going to hit twice, or it's going to be a bounce on it, is how I taught you guys last year. So let's do end behavior first. So this one points down. This one points up. So points down and up. So multiplicity of 2, so any even numbers of multiplicity is going to bounce on it. So it's down, and then it stays down, is what the graph should look like. And that shouldn't look like a point. It really should look like this. And it like hits at the 2. It's not a sharp curve. My graphs always look like sharp curves. Don't make it a sharp curve. So if the multiplicity is even, then it's a tangent to the x-axis, which means like right here, it just hits it and bounces back. If it's odd, it's going to actually go through it. So let's go ahead and we're going to state our zeros. So 1 is a 0, 3/2 is a 0, and -4 is a 0. The one happens twice, that one happens twice, and that one only happens once. So this one should be a tangent. This one tangent, which means it's going to bounce right there. And this one should go through it. So that's going to intersect. See how this one intersects right there? It goes through the 0. Next one, let's try. So I have to factor this. I'm going to put an x cubed. I get x squared plus 8x plus 16. So I get a 0 and a -4. This multiplicity is 3 because there's 3 of them here. This multiplicity is 2. So that one should intersect our graph. And this one should bounce on our graph and should be a tangent line. So let's go ahead and look at this. So this is an up-up function. It has to be even because it points up-up. Remember, evens go up-up. Oh, you can't see, sorry. Evens go up-up or down-down. So this is definitely even. The leading coefficient had to be positive because it's going up-up. It hits the graph, the x 1, 2, 3 times. So there are 3 extremas. There's a -3. It hits at 0 and it hits at 2. This one has to have a multiplicity of at least 2 because it bounces. This one, do you see how it kind of comes down and it swirls and goes through? That would make it a multiplicity of 3. So see how this one directly goes straight through? That's what a multiplicity of 1 looks like. This is what a multiplicity of 3 would look like. So then that's that right there. So this end behavior is down, down, which means it has to be an even function. And the coefficient had to be negative. Extremas, we have 1, 2, 3, 4. So I have that there are, the extreme values. Oh my lordy, it's been a long weekend, sorry. The extreme values are not the zeros. That's how you find them in AP Calculus. Let me go back over here. The extreme values are your max and mins. So here's one, and there's one. Over here, my extreme value is 1, 2, 3, 4, 5. So there are 5 extremas. Now the zeros are what I just found, and that's those 4 right there. So I have negative 3, 0, a negative 1, a 2.5, and a 4. And this one bounces, so it has to have a multiplicity of 2. That goes straight through. This one goes straight through, and then this one bounces. So that's the multiplicities. Let's see, end behavior here is up, up. It has to be even. It's positive. Extremas 1, 2, 3. The zeros of this one is like negative 0.5. And then this looks like maybe it goes through twice here. Doesn't that look like that to you guys? I think that this is actually coming down and hitting through here again. The answer key says negative 0.5 and that it's supposed to be a squiggly line, but I'm unsure of that. And so there has to be also one here at like negative 1. So negative 1 looks like it has a multiplicity of like 1, but this one looks like it has a multiplicity of 3 because see how it kind of squiggles right there to me? And then at 1, it bounces, so that'd have a multiplicity of 2. And that would make sense because that's 6 numbers, and that would be an even number. All right, so down here, let's factor this first. So this factors in x squared minus 4, x squared minus 25. So this would really be x minus 2 and x plus 2, x minus 5 and x plus 5. So if we are going to graph all of these right here, we're graphing it at plus and minus 2, 1, 2, 3, 4, 5. So a 5 and negative 2, 1, 2, negative 2. So this is a positive even. So better go up, up. So pounds is here and here. And then none of these are bouncing. All the multiplicities are 1. So I'm going to go an even curve like that. Okay, well, here's the end behavior. It goes up, up. So down here, I'm going to put a negative x cubed. So do your AC to that, and you should get 2x minus 1 and x plus 3. So I have a 0 here. That's a multiplicity of 3. I got a 1/2 and then a negative 3, and both those multiplicities are 1. This is a negative odd. So negative odd should go up and then down. Okay, these two dots are really close to each other, sorry. So up, down. None of these are even numbers, so none of them need to bounce. I just need to kind of make that look like a little squiggly line at the 0, which looks really hard to see because they're so close together. But that's what that is. All right, this one's already factored for us. There's 2, 3, 4. There's 4 zeros and it's negative. So this graph should be going down, down. My zeros are negative 4, 1/2, and 4. Multiplicity here is 2, 1, and 1. So it goes down, down. Multiplicity of 2 means it's going to bounce at that point right there. So it kind of goes like this, and then a smooth curve from there.